Okay. So we are getting into fractions today. How are you guys with fractions? Does anybody have some hard times working with fractions? Adding, subtracting, multiplying, dividing? Here and there. I got some people type in. Humbled enough. I hear you, Jay. Yes, the long division is definitely sometimes can get people, especially if you haven't used it, right, in a long time. Again, like I was saying, I was actually just having this conversation with my my fiance there that, you know, it's very easy to forget some of this stuff if you haven't done it. And even when I started doing the online math, I had to go back into my books and do a little refresher for myself. All right, so yeah, it's a matter of practice. And you guys can see, I don't know if you noticed or you heard me say, I am recording this one right now. So I will provide you guys with the link, and it is just this screen that you see here. All right. So when we talk about fractions, guys, if you see here, fractions describes a part of a whole. So think about a pizza, a ruler, right? So even think about your inches, feet, things like that, right? And even time, we can have a fraction of time, right? Minutes are a part of an hour. Seconds are a part of minutes, so on and so forth, right? And you can see here that I've kind of put it out in an illustration, right? There's our whole. This one here, I've got it split into two halves. However, I've got the whole thing, or both halves, two halves covered in. Essentially, it is also a whole. Same thing over here, right? You see, I've colored in all four quadrants. It was cut into four, just as this was cut into twos. And then you see the pink one over here, I've cut it into 8. All right? So when we look at that fraction, we have two numbers. You have the top number and the bottom number. The top is called the numerator. The numerator is the parts or pieces of the whole, which is the denominator. So if you look back up to my pictures here, right? When we look at the two twos or two halves, the bottom number or denominator tells us how many pieces this whole was cut into. Well, we cut it into two pieces. The top number, the numerator, tells us how many pieces we've, say, eaten if we're talking about a pizza. And I've colored in two pieces of a two-piece cut pizza. If I look over here at the quarters, right, the bottom number again, or the denominator, denounces how many pieces I'm cutting that whole into. All right? And I've colored in all of the pieces. Same thing over here. So if you guys notice that if we have the numerator and the denominator the same number, it's essentially equaling a whole. Do you guys see that? Right? And that comes down, and we're going to talk about that when we get down into our improper fractions. Right? But like I said, so denominator is the whole amount, just how many pieces is it cut into, and the numerator is the number of parts or pieces. We also call these terms. You're going to hear me refer to terms or lowest terms and things like that as we go along. When we get into equivalent fractions, so equivalent fractions have different numerators and denominators, meaning different top numbers and bottom numbers, but they still have the same value, right? So I wrote down here that 5 dimes still equal 50 cents. So does 2 quarters still equals 50 cents. Right? And if you look at my illustration here, I've taken the same square, I've cut it into multiple pieces, but I've colored in the same value. Right? So if you look over here, I cut this piece into 2, or into 2 halves. I've colored in 1 half. But then when you look over here, I've cut this now into 4 pieces, but I still have the same value, or that half, colored in. But this time, 2 out of the 4 is colored in. Same thing when I get over here. I've just taken the halves and cut them into 8 equal parts. Right? This is what we call the equivalent fractions. Do you guys notice how they essentially are all the same value? We just have cut them into smaller pieces. Right? If I had a pizza and I just cut it in half, well, I'm going to get a big portion, and so is the other person that's eating with me is going to get a big portion. But the more people we have, the smaller that the portions become. Think about it when we look at a tape measure. Right? Actually, this one might be easier to look at. Oh, where did it go? I had a sheet out for you. That's okay. So if I look at a tape measure, right? So if I look at, again, I'm just going to go from the 4 and the 5 because it's kind of easier to see than going down to the 1 here. But the 4 and the 5, that's 1 inch. If I cut it in half, right? Half is the same as saying 2 quarters. There's 1 quarter, 2 quarters, right? See it there? Cut it in half. It's also the same as saying 2 quarters. It's also the same as there's my 1 half again, but these tickies here, 1, 2, 3, 4, these are 8ths, right? And it's the same, 4 8ths is the same as 1 half. Okay. So when we go forward, I'm going to come back to this page to also talk about lowest terms and common denominators. So we'll keep this one in mind as well. So equivalent fractions, again, they may have different top and bottom or numerator denominators, but they have equal value to each other. A proper fraction, essentially these are equivalent fractions, but they're also written as proper fractions, meaning that the numerator, or again, the top number, is less than the denominator, or the bottom number. Essentially, a proper fraction is always going to be less than 1. It is less than a whole. It is a part of a whole. Okay, that is a proper fraction. Now, an improper fraction, where the numerator, or again, the top number, is equal to or greater than the bottom number or the denominator. Essentially, what an improper fraction is, the value is either 1 whole or more than 1 whole. Okay, and I've given you an example down here. Here I've taken my square, I've cut it into 2 pieces, right? I wrote something funny here. Oh, okay. I was showing you 2 different things here. So this one here split into 2 halves. Remember I said value of 1 or more. Okay, split it in half and given away to both pieces of my pizza. 2 over 2 is essentially 1 whole. Okay. I can also look at, again, my numerator could be bigger than my denominator, as I have in my 5 over 4, or 5 quarters. this is essentially what it's saying is I have 2 pieces of pizza essentially. I've cut them into quarters, 4 equal pieces. 1 whole pizza, right? 4 over 4 I've given away, plus 1 more piece of my second pizza, right? So there's where you see the 5 over 4. Essentially, we can also write it as 1 whole and 1 quarter. This is called a mixed fraction. How are we doing so far, guys? Are you guys making notes of this? Is anybody writing these ones down? Do you want me to leave it there for a quick sec?
Yeah, 1 second, please.
Yeah, absolutely. I'm just going to put a quick little pause here on the video. There we go. Okay. So with the mixed fractions, as I mentioned, mixed fractions are essentially a whole, plus it could also have part of another whole. All right. So we saw the one previous where we had, we split our shape into quarters, 4 equal pieces, right? And we had the 5/4, which was essentially 1 whole and 1 quarter of the next pizza. I've taken 2 shapes here and I've cut them both in halves. But I've essentially given away all 4 of my halves, right? 4 over 2, or essentially essentially 2 wholes. Do you guys notice that? Right? So 4 2s is the same as saying two wholes. All right, and I'm going to get down into showing you how to properly convert those back and forth. I kind of want to get the terminology and the definitions out of the way first so that we can dive a little bit more head on into the calculating. All right, but again, mixed fractions are wholes, or they can be wholes and part of a whole, as we saw back there. Okay. I mentioned I was going to say something about lowest terms. Lowest terms is essentially reducing a fraction down to its lowest equivalent. And if you remember what a lowest equivalent is, right? Here's our equivalents. So if I was to take 8/16, remember we said they're the same value, but the smallest way of writing it, or the lowest term, would be the 1/2. Does that make sense? Right? It's the lowest way of describing it. By the way, I want to point out that these split screens don't show up in the video. It's only the live screen. So yeah, when you guys, if you watch the playbacks, do realize, yeah, we're missing the split screen. That's why I say take some notes. So there we go, our lowest terms. And as I've wrote it here, lowest terms, reduce the fraction to the lowest equivalent. And again, I wrote it as the 8/16, also equals the 4/8, the 2 4s, or the 1 over 2. All right. Essentially what we're trying to find out is what will go into both of these numbers to bring it down into its lowest. And if we looked at the 8/16, let me move that cursor. 8 will go into itself once. 8 will also go into 16 2 times. So that's its lowest equivalent fraction to 8/16. You may come across some crazy numbers like 9 over 32. It may not be able to go any lower than that, right? So lowest terms, the lowest way of writing an equivalent fraction. When I talk about common denominators, remember denominator is your bottom number. And common denominators mean that all of the bottom numbers are the same, right? Now, I've written these fractions out right here. Let me just get rid of this. So you see 4/8, 2/4, and 1/2. Well, the numbers are all different. But if we were to have to add our fractions, we need to have all of the denominators the same, right? Apples to apples, oranges to oranges. Right now I have an apple, an orange, and a pear, right? I can't add those together. So I have to find a common denominator, right? A number that is a multiple of all of the bottom numbers, meaning a number that the 8 will go into evenly, as well as the 4 and the 2, right? So if you see I went over here, the common denominator actually happens to be the 8, because 8 will go into itself, but the 4 will also go into the 8, and the 2 will also evenly go into the 8. Okay? 4 and 2 are both multiples of 8. And you notice how when I turned them into 8s, or apples, right, the top number changed as well. So essentially when I'm trying to find a common denominator, whatever I did to the bottom, to say in this case turn it to an 8, I have to do the same to the top. So I take the 2/4. To make that 4 an apple or an 8, I had to multiply it by 2. Well, then that means I have to do the same thing to the top number. And I multiplied it by 2 to get the 4/8. Same thing with the half, right? I have to turn that 2 into an apple or an 8. So in this case, I multiplied it by 4. Well, then I have to do the same thing to that top number. Once they are all the same denominator, if this was an addition or subtraction, I can now do this freely, and we'll get into that momentarily. When I look at this set of numbers, right, this one was easy because those are even numbers, and it usually works out to at least a 2 can go into even numbers. Look at this one here. I have 1/5, 3/4, and 1/2. I need a multiple common to all of these numbers, right? And the only one that I could find was the 20. Because 5 will go into 20 4 times, right? 4 will go into 20 5 times, and 2 will go into 20 10 times. And you can see that down here that I've taken the 1/5, the 5, I multiplied it by 4 to get the 20, and I have to do the same thing to the top to get my 4/20. 3/4, well, I had to multiply the 4 by the 5 to get the 20. And then same thing with the top. And I come down over to here to the half. It's also the same as saying 10/20. Essentially, I took an apple, orange, and a pear and made them all into apples, right? Something that we can deal with when we're adding and subtracting, right? So now I have essentially taken all of these numbers here and put it into an addition question. We need them all the denominators to be the same because when we add and subtract, that bottom number doesn't change, right? It stays the same. It doesn't go 20 plus 20 plus 20 plus 20 or equals, 60. It stays the same. Apples, 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 and we're leaving off with an apple. It's only going to be the numerators that we add up. And in this case, 4 plus 15 plus 10 equals 29. All right, so far so good? Cool. I put a little star right here because what this one's called is an improper fraction, right? And we kind of mentioned that on our last page, right? Remember, improper fractions are fractions that the numerator, or the top number, is either equal or greater than the bottom number, right? And there's our mixed fraction there. The numerator is bigger than the bottom. So essentially, what this one is saying is that we have at least one whole and a part of a whole. All right? Essentially how it looks here, and we're going to get into that converting in a moment, but it's like saying 20 over 20, right? Again, it's that whole. And then we had 9 other pieces of that 20-piece pie. So far, so good? Does it make sense? Kind of, sort of? Right? So you see I wrote it here. 20 over 20 is the same as one whole. It's the same as saying 2 over 2 or 4 over 4. Right? If these are the same, it's essentially one whole piece or one whole object. The leftover 9 is part of another object that was cut into 20 pieces. 1 and 9/20ths. Now, if I was to say, bring it down to your lowest common denominator, or lowest term rather, this is as low as this goes, because there isn't a number that will go into both of these numbers evenly, right? Sure, I can split 20 into 2, but I can't split 9 into 2 evenly. I'll end up with a decimal or something like that. Again, a part, right? So that is our improper fractions, where we have the numerator bigger than the denominator, and if we had to add or subtract, we need common denominators. All right. I'll leave that one there for a quick sec if you guys want to make any little notes there. I think I zoomed in. Nope, I guess I didn't.
I have a question.
Yes, please.
So if we want to convert the 9 over 20 to a decimal, so how would we
We're going to get to decimals maybe by the end of tonight, right? But you are definitely, if not tonight, it's going to be our Tuesday one. Because, yeah, we can get those into decimals. And some people prefer to convert it into the decimals because decimals are easier to deal with, right? Easier to quickly calculate. Because it's essentially like, what's that?
It's easier to add or subtract them?
Yeah, decimals, because it's essentially like working with whole numbers, right? We'd be stacking them the same way. Calculating fractions is a little bit different, okay? And I'm going to get to that one in just a moment here. But I want you guys, let me get into this improper real quick. Converting improper and mixes. So here, converting an improper fraction to a mixed fraction. So once again, remember, an improper fraction is the numerator or top number bigger than the denominator. Alexa, stop. Sorry guys, I have an alarm that goes off at 5:30 to remind me to feed my animals. All right, so essentially an improper fraction is either going to be a whole or a whole and more. All right. So if I want to turn a improper into a mixed, this is essentially what it's going to do. Remember when we were dividing on Tuesday, right? And I said you can either have something written like this, right? 5 divided by 4, or essentially this is the same sort of thing. 5 over 4 is saying 5 divided by 4. And here I have it written out nicely, right? So 5 divided by the 4, right? So the 4 out here is my denominator. That's not going to change. It's going to continue to be the denominator. But 4 goes into 5 once, right? 4 times 1 is 4. When we do our long division J, right, it becomes a subtraction. So 5 minus 4 equals 1. So the number that goes up on top, that's your whole number. How many times can 5 go into, how many times can 4 go into 5 evenly? Well, it can only go in evenly once. There it is there, right? So I've circled that in blue. Blue is your whole number, and there it is there. I mentioned that the 4 remains the denominator, so there it is over there, and the remainder becomes my numerator. Right? So again, we said that it's either going to be a whole and a part, and there it is there. So 4 fours plus the 5th. 1 whole plus 1 quarter. Because again, the denominator tells us how many pieces our shapes are being cut into. Okay. So I want you guys to try these two out. I want you to try the 13/8 and the 21/16. Okay, so again, remember, we can write it like this if we'd like. When we say 13 divided by 8. Well, 8 goes into 13 once. 1 times 8 is 8. Remember, this becomes a subtraction. 13 minus 8 is 5. Okay, for the sake of being cool and color-coded, right? Remember, this becomes our whole. This is still our bottom or denominator. And this remainder becomes our numerator. So yes, 1 and 5/8. Okay? I'm just going to split that there for a sec. So same thing with our 21/16. Again, if it helps to write it out as long division, 21 divided by 16. 16 goes into 21 only once, right? 1 times 16 is 16, right? Remember, it's a subtraction. Might as well just do our long division for shits and giggles. Right? We can't take 6 away from 1, so we're going to borrow. Right? 11 minus 6 is 5. Right? No. Yeah? Right? And our 0. So again, we have our, where's my colors? Our whole. Our denominator stays the same, and that's our remainder. So 1 whole and 5/16. Meaning if I was to draw this out and make shapes, right, my shape would be cut into 16 pieces. And I would have one of these shapes, all 16 pieces colored in. And on the second shape, only 5 of those 16 pieces are shaded in. How we feel about that, guys? Okay, so far? So that was improper to a mixed. So taking our bigger numerator and turning it into something with wholes and fractions. Now for a mixed, right, into an improper fraction, right, we're going to essentially, and here I've kind of highlighted it with the colors again, there's our whole, our numerator, and our denominator. the thing with this one, and I like to draw it out like this, essentially you're taking or multiplying the whole number by the denominator and then just adding the numerator. So we're going to go 1 times 2, which is 2, then add the 1, 3. So the 3 goes up as the numerator. The denominator always stays the same, right? We're just now making a improper fraction. And there it is drawn out as shapes. All right. So when I mentioned about common denominators needed for adding and subtracting fractions, improper fractions are actually needed to multiply and divide, right? I can have different denominators. They don't have to be two apples, right? I can have quarters and thirds and still multiply them. But for adding and subtracting, the bottoms or denominators have to be the same. Multiplying, dividing, I at least have to have them in improper fractions. So I want you guys to go ahead and try putting these two mixed into impropers. Okay, so again, remember when we're turning the mixed into impropers, all we're going to do is multiply the whole by the denominator and then add that numerator. So again, this is going to be essentially 2 times 4 plus 1, right? 2 times 4 is 8 plus the 1 is our 9. Again, remember that denominator stays the same. So 9 over 4. Right? Same thing over here with our 9 1/3. 9 times 3 plus the 1. So I like the black pen. 9 times 3 plus 1, right? 9 times 3 plus the 1. I showed you guys that trick already. 9 times 3 is our 27. 27 plus 1, 28. Again, that denominator stays the same. Good, Philman. How'd you guys do with that?
I kept on forgetting to add.
Add the top one?
Yeah.
Yeah.
I've got 8 4s and 24 3s.
Ah, yeah. And that can happen. A lot of people tend to forget that. And I don't know why. That's why I kind of like this little throw my multiply there and my little arrow. Right? That's just my way of writing it. It's quick. It kind of keeps my brain kind of in order. Again, some of this color coding is for your benefit, but also mine. It keeps me organized, right? So not too bad. What's that, love?
Another way I remember doing this is just to write make the whole number into a fraction. So like you would write 2 over 1 plus 1 over 4, and then you would multiply.
Yes. Yep. And you know what? We're going to do some of that when we get into the multiplying and dividing. For sure. Good.
Okay.
And that's the beauty about the math, right? Kind of like what Kenny was saying as well. That even though there is a definitive answer, it's not like you can get a different answer for this equation right here. It's finite. It's just there's different ways to calculate it, right? And whatever works best for you. For the sake of these programs, I tend to try and really break it down to its basic foundations. A lot of times I wouldn't be writing out some of the longest stuff, But it's being able to know how to do it the long way in case something was to happen, in case I don't have a calculator, in case my phone died, right? Things like that. But yeah, pretty cool.